the first thing to think about, of course, is what exactly is a smart contract, right? And so what I want you to think about a smart contract as, which is pretty much exactly what it happens to be, is it's just code which is uploaded to a blockchain. So when you think about something like Bitcoin, you think about things like payments on this digital ledger. Now think about a chunk of code being deployed on this digital ledger, okay? And so what goes into that? Well, there are two main things that go into that, which is generic to essentially any chunk of code in let's say an object-oriented programming language, which is attributes and functions. Sometimes these are called variable, and sometimes attributes are called variables, sometimes functions are called methods, but the point is they're basically two pieces. And what are the two pieces more precisely? Well, the attributes are there to capture the state of the system, whereas the functions are there to enable updates to the system through, for example, in this case, the users of the blockchain. And so I'm going to give you a specific example in a moment that is very blockchain specific, but for the moment, this conceptualization is actually broader than blockchain. And so let me offer you a simple example in life that you should all be familiar with, which is, for example, you're all students at NYU. So you all have sort of an identity in the system of NYU, and there's a state to that identity, meaning, for example, your GPA is an important state variable as far as your college career at NYU goes. So if you were writing a code structure that's supposed to sort of keep track of students, one of the key attributes would be something like your GPA or the number of credits you've taken, because you have to take a certain number of credits to graduate, right? But the point is your GPA today is not your GPA forever, and your credits today is not your credits forever, because to graduate, you have to increase your credits and your GPS to stay above a certain hurdle rate. So there has to be a way to update the GPA, the credits, etc. And that would be through the functions, okay? So any sort of system you're thinking about, you have to have a state for it if it's at all complicated, and that's going to be captured by the attributes. But the state can change. And so that's where the functions come in. And so these chunks of code are going to have both of these pieces, okay? And again, hop in if there are any questions here. Before I dive into the specific example on blockchain though, let me say that all the code I'm going to be showing you comes from a particular blockchain, which is called the Ethereum blockchain. And the reason I'm going to be using that is because it is the most prominent blockchain as it pertains to smart contracts. So almost all of the decentralized finance activity that you may have heard of is running on this particular blockchain called Ethereum. So every code chunk you see is Ethereum, and most of the content is going to be specialized to it. And that is also, by the way, the blockchain on which we're asking you to think about proposing a business idea, right? Okay, so rather than using some example that you would never see deployed on blockchain, like student records at a university, let's use a really prominent example that has been deployed on blockchain to the tune of generating billions of dollars of capital, and that is something called an initial coin offering. This was particularly famous a couple of years ago. It's died down a bit, but nonetheless, it is a significant sort of blockchain application from the past. And so what is an initial coin offering? Well, as the name sounds, you basically create a new class of coins and you sell them. And the initial coin offering refers to sort of the initial sales, right? You can think of it as kind of parallel to an initial public offering where you're offering out stock, except in this case, you're basically just inventing a class of coins, right? So you can create a coin named after yourself and say, I'm going to issue 1 million of these or something like that, right? And that's really what an initial coin offering is. So where does the blockchain come in? Well, the coins are created and sold through a blockchain. So the settlement process, for those of you finance majors familiar with the notion of trade settlement, the settlement process for these coins occurs on that digital ledger that defines the blockchain. Okay, that's the link. And so the consequence of that means that, for example, if I'm going to buy one of these coins that you create, it corresponds to activity on the blockchain because the place that it settles is the blockchain. So it must be registered there that I bought it. And so how does this work? Well, basically, somebody has to upload a smart contract to, for example, Ethereum. And that contract, remember, it has two key things. It has attributes and it has functions. So the attributes are going to be there to capture the state of what's going on. What is the state of what's going on if you're issuing coins into circulation? Well, for example, one of the key things is the balances, right? If you're going to buy a coin from somebody, you want it to be registered somewhere so that, for example, you could sell it. So the system needs to keep track of the fact that you bought something so that you can later, for example, sell it, right? And so when it comes to the attributes, as I'll show you in a moment with actual code, one of the key things is the balances. There's going to be other pieces there too, but one of the key things that's going to store as part of the state of the system is just the balances. Who owns what? Okay. But the fact that you don't, the fact that you own something right now doesn't mean you're going to own it into perpetuity. Maybe you want to sell it, right? So the point is that state is not static. It can't be static, otherwise this thing is useless, right? And so you need functions that can allow, for example, transfers of tokens, right? So initially, for example, nobody's going to own anything, and that can't. So that's the state of the system, but it can't be a perpetual state, because then how is this actually going to work? You need a way to sort of transition the system, and that's where the functions are going to come in. So as I said, purchases, transfers, those sorts of things is what the functions are going to do. But let's make this a bit more concrete. So I was told that all of you have some coding familiarity, so hopefully this doesn't jar anybody, but in case it does, remember you're doing your project in groups, so find somebody who doesn't get jarred by it if that's the concern. But what I have here actually is some code from a particular initial coin offering. So the code is actually very standard, and it's actually very easy to do an ICO. I've done it. I did actually multiple times for classes that I was teaching, just to show students how to interact with it. So this is actually quite standard of a lot of code chunks associated with ICOs. But here what I have is basically I've screenshotted a part of the code that shows you some of the attributes. Okay, so let's look at it slowly. Like if I look at the first line, it says uint public total supply. So that is one attribute. The line below it is another attribute, and the line below it is another attribute, and the fourth line is another attribute, and then there's nothing in the fifth line, but the sixth line is a fifth attribute. So what you're seeing here is 5 attributes, and it's laid out kind of like you would expect in a language like Java, where the name is at the very end. So underscore total supply is the name of the first attribute, but the other 2 pieces of information are telling you things about it. So for example, when you're storing information for the state, you could store it as a character string, or you could store it as an integer, or you could store it as what's called a double or a float, meaning non-integral number. And the computer, of course, needs to know this. So that first word there, uint, stands for unsigned integer. It's telling you total supply, which you may not be surprised to realize means the total supply of coins for your initial coin offering. That, of course, is an integer. Okay, so the uint is just saying the data type. It's saying what it is. Public is just a statement of access. So this means that sort of anybody can access it. And it's really, I think, for this case, technical detail we don't need to get too deep into. But the point that I'm making is think about the application here, right? Which is you are selling coins. Do you think it's useful to know how many coins are already in circulation? Well, probably, right? If I go to Yahoo Finance and I check out like basic statistics for stocks, they typically do tell me the number of shares outstanding. That does seem to be like a relevant, let's say, statistic when you're thinking about any sort of financial asset. And so that is in the first line. That's what total supply is. Now, the next 3 lines, start date, bonus ends, and end date, actually are more specific to the idea of the ICO, because you have to remember it's an initial offering. So an initial offering, of course, doesn't go on forever. You can't get into the initial public offering for Google right now, unfortunately. You probably would love to, since given how well Google's done over the couple of decades it's been around, but the initial public offering is over. And so by the same context here, the initial coin offering has a start date and it has an end date, right? And so after the end date, you can't get any more into the initial offering. The bonus ends, as you will see, is actually an incentive mechanism, which is that if you get in between the start date and the bonus ends date, you get better pricing than if you get in between the bonus ends date and the end date. But you'll see that actually more clearly in a moment. And in some sense, that's really more just details around the ICO code. the last one I want to really point out to you, I want to emphasize here. So it says balances, right? One of the points I made earlier is, of course, an important piece of the state of the system is going to be who owns what. So how is who owns what stored? That is the way it's stored. And what do I mean by that? So you see the data type precedes the name. The name is balances here, but what is it exactly? It's not an unsigned integer. It's not a uint. It says mapping, and then it says address, and it's got this arrow, and it says uint. So for those of you familiar with Python, think of dictionaries in Python. This mapping data structure is a dictionary in a different coding language, and they use a different name for it. If you're familiar with Java, think about a hash map. Essentially, you have keys mapping into values, and so this address arrow uint is telling you these keys map into those values. And so specifically, what's going on is, how would I keep track of balances? Well, I have to. It's going to end up being something like saying, okay, Professor John owns 5 of my tokens. Okay, so how do I store that? Well, the key is going to be something associated with Professor John. Now, these are not, you don't put your name on the blockchain. It's a pseudonymous system. So Professor John is going to have an address, which is, I mentioned earlier, maybe we'll have you generate an Ethereum address through an Ethereum wallet in a future instance. But the whole point of doing that is that you get an identity in the system. And so what I can do is with that identity, I can say, oh, okay, this identity, that's the key. The value for that identity is the amount of coins that person actually owns, which is why, by the way, it's an address and then an arrow, a uint, because your balance is a number, or a uint, if you like. But you in the system are, if you like, an address. And so this is just saying that the way we keep these balances is essentially like having a dictionary where, next to your name is the number of coins you own. And of course, we can change the dictionary over time, which would correspond to you buying and selling, for example. But so these are important state variables if you want to issue a coin, of course, right? And that's what you're seeing here, literally for a chunk of ICO code that is actually deployed on the Ethereum blockchain. But let's bring this a bit more to life by bringing the functions into it. As I said, the attributes give you the state of the system, right? But the state of the system is not static. You're not going to want to keep your tokens forever or your coins forever. I assume you're going to want to sell them at some point. And in the first place, you're not going to be born with them. You're going to have to buy them, right? So actually, probably the most important function in the ICO code is the one that actually executes the sort of initial purchases, the purchases in the initial coin offering. And that is actually the function that I have in front of you here. For this particular case, let me actually walk you through it. So the first line is the function declaration. And you might wonder why there's not a name after it where it says function. That's usually typical, whatever language you have it. You have kind of the type of thing it is, let's say function or method or whatever, and then you have a name. Here you don't, because this is actually the default function, meaning you actually don't have to specify what function you're talking to if you're calling this function, which is why there's nothing there. Hold on, we have a question in the chat, I guess. Alex is asking, this is in Solidity. Yes, this is all Solidity code. Anyway, so let me move on here. So basically, the first line is actually kind of unusual because of that. There's not actually a name to this function because it's the default function for this contract. But let's look at let's look inside the code. Okay, the first line says require now greater than or equal to start date and now less than or equal to end date. So that is not something you would see in Java. That's something specific to Solidity. All it really is a line of code that is like a conditional escape. So in other words, it's going to check that condition. It's going to say, what is the date now? And you remember start date is one of the attributes. So it's going to say, is today after the start date? Because you can't buy anything until we're after the start date. And okay, if that's fine, then is today before the end date? Because you can't buy anything after the end date. So in other words, are you in the ICO period? And if you're not, it'll just escape out of the code. If you are, it'll keep going. So the only way that it's going to go past that first line, the require line, is if the thing inside is true, which basically in English maps to saying we're inside the period that was specified as the ICO period. Okay, then you declare an integer. It doesn't matter what the name is here. The name is tokens. And what's it doing? Well, it's saying if now is less than or equal to bonus ends. So remember, there were 3 sort of dates in the attributes, right? There was a start, the end, but there was a bonus. And so now it's saying, okay, we know you're inside the ICO period between the start and the end. Are you before the bonus period? If you are before the bonus period, this token's value, we're going to take this MSG.value is actually just the amount of ether that you're sending into the contract. Okay, so just take it as given. It's more of like a core thing in Ethereum, which we can kind of abstract from for a moment. It's the amount that you're willing to pay. Okay, so it's going to say whatever you're willing to pay. Let's say you're willing to pay 1 ether. If you're before the bonus period, I'm going to take that 1 ether and multiply it by 1200. So you'll have 1200 tokens of whatever token I created. Let's pretend that I created a token called NYU token. I'm going to give you 1200 NYU tokens for every ether token that you give me, is what that line at 222 is saying. But only if you're inside the bonus period. Else, if you're not in the bonus period, I'm going to take that 1 ether and give you only 1000 NYU tokens. So what did I say? I said the bonus period is actually an incentive mechanism, because if you want more tokens, come in early, right? Buy the tokens early if you want the tokens, because you get 20% more. These are numbers that you can basically choose when you deploy the contract. So, you don't have to go with these specific numbers, but I'm just saying this is what this code is saying. It's saying you go in early, you get 1200 per ether. You go in late, you get 1000 per ether. So you have an incentive to come in early. Okay, now what do we do with this thing? Well, remember, the thing that determines whether you actually own the token is that dictionary, which they call a mapping. And that dictionary was called balances. So now they're going to invoke that. They're going to say, okay, so your MSG.sender is whoever is interacting with this function. Okay, so if you're sending the ether, you're MSG.sender. Okay, if Professor John is interacting with ether, he's MSG.sender. So this is saying now, okay, let me go to the value associated with, let's say, Professor John in this case. Okay, that's balances, and I evaluated it at MSG.sender. Well, Professor John may already have a balance, right? He may have this. That's why this is safe add. It's an addition. It's an addition operation, and he may already have a balance. So I don't want to just pretend that he's going to have the value I computed for tokens. What I'm going to do is I want to take what he had before, and I want to add this number I computed tokens. I want to increase his balance by whatever is this number that I just computed. So for example, if he already had, let's say, 500 tokens, and then he sends 1 ether in, and it's before the bonus, then I'd say, okay, you had 500, that was the previous balance, and then you'd have the value 1 times 1200, that's an additional 1200, that's what tokens is, right? So you'd have 500 plus 1200, okay, so now the value is going to be updated to 1700. And that's, by the way, all it really means for you to own one of these special tokens, okay? Like, even if, for those of you familiar with something like Tether, Tether is also an ERC20 token that lives on the Ethereum blockchain. It lives on a few different blockchains, but one of the places it lives on is on Ethereum. And what does it mean to own Tether? It means in the balances data structure, in the Tether contract, if I look up your Ethereum address, it will have that particular number in there, okay? That's how balances are stored in the world of Ethereum for these tokens that are the created tokens on the platform over top of Ether, okay? So that's what 226 is doing, okay? 227, of course, we are giving tokens to Professor John, but that also means we're increasing the outstanding supply. So remember, there was an attribute total supply, which is the total outstanding circulation of this thing. So we're also gonna have to change that, right? Whatever it was before, you gotta add the number of tokens we're giving to him, because those are new tokens. They're brand new. They're not, he's not buying it from somebody who already owned it. This is the initial offering, not the secondary offering. This is the primary market, not the secondary market, okay? I see we have a raised hand. Why don't you, can you go?
Linda, you have a question?
Oh, yes, Professor. So like for the safe add, I mean, the method. So like if somebody doesn't really have like an account or a record in the mapping yet, can just this function like just add the tokens the person just purchased?
Right, so there are different conventions across languages. I think part of what you're getting at is that certain languages will throw an error if I call the balances of key when there's no key, when I haven't used the key before. But some languages actually won't. And I believe in this case, actually, the reason for the safe add is more due to issues having to do with finite precision of arithmetic, rather than the data structure being such that you can't call something that's empty. In this case, I think if you call something that's empty, it's just going to treat it as 0.
Okay.
Okay. So 226 is updating Professor John's specific balance, or more generally, whoever is behind this interaction. And 227 is then kind of making the commensurate edit to the total supply of coins, because the coins that are being given to him is a new coin. So it has to also update the total outstanding supply. 228 is actually a bookkeeping thing, where it's sort of sending a message that you can sort of see after the fact that this transfer is happening. So you can kind of ignore it. Or sorry, 228 is a bookkeeping line. 229 is the flip side of giving Professor John the tokens. So Professor John is, let's say, putting up an ether to get some of my NYU coin, right? But then he better be giving away the ether, right? And so who's he giving it to? Well, he's giving it to the owner of the contract. So this owner.transfer MSG.value is saying basically we're going to transfer MSG.value from Professor John to owner. Okay, so owner is going to get the ether. Professor John is going to get the tokens. And a little bit of what's in the background, which I'll clarify in a moment, is that Professor John is sort of triggering this function to be called. And so it kind of knows who he is already. And it doesn't sort of need to make as many explicit references to him, but I'll clarify that in a moment. But hopefully the basic structure of this contract is clear. And again, this is actually maybe like the most frequently called contract in the most frequently called chunk of code in the history of Ethereum, because almost all ICOs have some code that looks like this, and the initial coin offerings run through this code. And of course, that was a massive fascination, particularly in 2018, when it raised billions of dollars for various entities. But okay, hopefully we have some sense now what attributes are, what functions are, and what a smart contract is. But let me kind of come back to this point about, I was saying Professor John is triggering the contract, right? But so what exactly am I talking about there? So it turns out that you can still think about the blockchain as just a bunch of transactions that are, put together in discrete chunks. In the same way that in that paper that Professor John sent you that talks about Bitcoin, says, just think about it as a bunch of transactions in discrete packets, where the packets are called the blocks. You can, despite the complexity, despite the fact that they're not, simple transactions, even in the world of smart contracts, it still boils down to a bunch of transactions that are packed together in a block, and the blocks being concatenated together. And the reason for that is the notion of what a transaction is richer. So let's be more precise about this then. Just like users have addresses on the Ethereum blockchain, which again, users have addresses on the Bitcoin blockchain too. The difference is smart contracts also have addresses on the Ethereum blockchain. Okay, so whereas in Bitcoin, it's just, you can think of it as people having addresses, and people can have multiple addresses. What's different here is that a chunk of code basically can have an address. And in fact, every smart contract does have an address. So I don't mean to say, I don't mean to suggest that there are smart contracts that don't. Every smart contract has an address in the same way that users have addresses. They're frequently referred to in different ways. We refer to them as contract accounts as opposed to externally owned accounts, which are user accounts. But so then when I was referring to this idea that, let's say, Professor John would trigger a function, how's that going to work? Well, what's going to happen is this contract has an address and Professor John has an address. And so what Professor John is going to do is he's going to construct a transaction where he is the sender and the contract is the recipient. Because remember, it has an address, so he can do that. And so literally what I've done is here I've gone to what's called a block explorer, and I have the website address at the end of the slides. And I've gone to this block explorer and I've actually taken a line from it where it shows the transactions in a block, and I've taken the first transaction to show you what's going on here. And so that you can see this row is one transaction, right? And so it has what's called a hash, which kind of identifies the transaction. And it's in a particular block because transactions are in blocks. So the particular block on Ethereum that it's in here, you can see is 5,777,281. And so you can, even go and look up this block and look for this transaction. And this is actually a very old transaction, as you can see. It was done 868 days ago. But the point is that you see under from, there is some, there's an address there, which is kind of purposefully not very nice for human reading because they don't want it to, reveal identities in the most obvious way. Like you don't want to say Professor John because he wouldn't be happy with having that, available to people. But the 2, it also has kind of a, an address there, and this is more of the interface of the particular block explorer that is doing this for us. But the point is, it has this little icon that is before the address that's under the 2. And if you hover over it, which is what I did before I took the screenshot, it says contract. So the nice thing about the block explorer that I'm referring to right now is that it even identifies for you. It tells you, this contract under from, it's a normal contract. It's like when a professor, it's a normal, it's not a contract. It's a normal address. It's a normal address. It's a user address. It's like, let's say, Professor John's address. But that 2 is not. That 2 is a contract. It's a chunk of code. There's nobody there. It's just a chunk of code. And so this block explorer is literally just telling you that, and it's making it easy for you to detect that. So that's, that's convenient. But the point is, how is Professor John triggering that chunk of code I showed you? Well, he's literally writing a transaction where he's the sender, and that address for that contract is what he puts in as the receiver. Okay. Now you might wonder though, a chunk of code can have a lot of different functions, and indeed they have lots of different functions. So how do you know which function Professor John wants to call? Now there can be default functions, as I said, and in that case that was the default function. But more generally, you want to allow some way to specifically identify a function to call, because maybe you don't want to call the default function. And so it turns out that separate from the way Bitcoin operates, Ethereum it has another field in the transaction that Professor John can identify when he's setting up the transaction. And that field is in the block explorer. You can see it under the thing called input data. And so what I'm doing here is I'm showing you what this block explorer is showing us for the input data. This is, by the way, this is actually not a transaction calling the default function, because I wanted to show you something calling a particular function. And so in this case, that transaction I just showed you on the previous slide, it's calling a function called transfer. And the function has 2 arguments, an Ethereum address and a number of tokens. And that shouldn't surprise you, right? Because maybe after Professor John got some tokens, some NYU tokens, maybe he wants to send it to one of you. Well, how would he do it? It would be useful if there was a function in the code, called something like transfer, where you could identify your address and the number of tokens he wants to send you. And that's exactly what this function is. And so below at the bottom, what I've done is I've actually screenshotted the specific transfer function, which is different than the function I showed you earlier, which also then highlights that there are multiple functions in this code, right? And he can call whatever functions as long as they're public. And so you see here this function. First of all, it actually has a name. It doesn't just say function in open parenthesis, close parenthesis as the previous one did. It has a name. It's called transfer. It has 2 arguments, a to address, who you're sending it to, and an unsigned integer, which is, how many tokens are you sending them? And it's a public function. And if you go through it, again, I think it's fairly intuitive what it's doing. It's saying, okay, so msg.sender, that's Professor John, right? He's the one triggering the contract. He's the one triggering the function. So it's going to take his address and look into this dictionary, or sorry, this mapping, as Solidity is calling it. And it's going to look at the value. It's going to say, oh, he has some value before, but he's sending tokens. So we're going to take it away. We're going to do a subtraction. We're going to take his value, take off the number of tokens, and then to the address that he's identified as the recipient, that's the 2, that's what we're calling 2 here, we're going to add to whatever balance they had the number of tokens he's giving them.